Hello and welcome, my dear grade 10 elite students, to my channel Mathematics Made Easy. This is Miss Ruchika welcoming all the grade 10 elite students who are going to give the exam very soon for today's very important session. And as you all were really requesting me from a long time, I have finally been able to get the time to make this video for all of you for the end of term 2 coverage. And today's video is part 1. We are going to be covering the most important questions, which are going to be multiple choice from part 1 of the exam coverage for all of you. So let's get started, and before we do that, a humble request, a kind reminder to like, share and subscribe to the channel so that it serves me as a motivation to make more and more videos for you. Before we begin into the questions, before we dive in and solve the questions that are going to be important for you, let's have a quick overview of your exam pattern for the coming math exam. So you have three parts, part 1, 2 and 3. Part 1 and 2 are multiple choice questions of 3 and 5 marks each. So 30 marks and 50 marks are going to be for the multiple choice questions, the first 20 of them. Then there are going to be three free response questions for part 3, which are going to carry 20 marks. That means you have to show your steps. It will be on pen and paper. So the online part is part 1 and 2, which will be on Swift access, and part 3 will be on the paper. So as per the instructions, as per the guidelines that have come, calculator is not allowed, and you have a total marks of 110 for the math exam and a time of 2 hours or 120 minutes to finish it. So in part 1, we have the following 10 learning objectives which are important. The page number and the examples are mentioned here. So let's start with solving them. Okay, so let's solve first the questions 1, 2, 3 and 4, which are on simple interest concept. And as you see, the formula for simple interest is P multiplied with R multiplied with T, where P is the principal, R is the rate of interest in percentage, and T is the time for which the amount is invested. So let's begin with the simple question number 1. Here you need to find the simple interest on an investment of $10,000 at the rate of 3.5% for time 8 years. So SI is going to be equal to 10,000 multiplied with 3.5%. So it is same as divided by 100 and multiplied with 8. So simplify it. Cancel the zeros, multiply the number, so this comes out to be $2,800. So the answer for this is $2,800. Next question 2, a saving account of $3,500 earned this much simple interest in 5 years. You have to find the rate of interest. So again, I'm going to use the simple interest formula. 875 is already given as the simple interest on the principal of 3,500. Rate you don't know, you have to find, and time is 5 years. So we have to just solve this expression. So when you solve it, and also remember the rate is expressed as a percentage, so I can divide by 100 so that I can cancel the zeros and the common factor. So you simplify, so R comes out to be 875 divided by 175, which is going to be 5%. So the rate of interest is 5% here. Question 3, Robin borrowed this much amount. This is the principal, the time is 4 years and the rate is 2.9. So I'm going to solve it here, answer 3. So the principal is 1500, the rate is 2.9, the time is 4, so divide by 100, and simple interest is what you have to find. Now you have to say, along with the simple interest, how much Robin will have to pay back in total. So first you calculate the simple interest by simplifying this, cancel the common terms, so this comes out to be $174. Now the total amount he has to pay back is going to be the principal plus the simple interest. So principal is already 1500, to it you add 174, so this is going to be $1674. So he has to pay $1674 back in return. Let's do number 4. In this one you have to find the time. The rate is given, the principal is given, the interest is given. So same formula we are going to use for finding the solution. So 2400 is the simple interest, 2500 is the principal, 8% is the rate and t is the time that you need to find. So simplify this, and when you simplify, time is going to be coming as 12 years. So the answer for this is 12 years. Next, we have questions on exponential form and logarithmic form. So the main concept we are going to use for that is log base. If the base is b, x is equal to y. If this is the logarithmic form, then you can convert to the exponential form in this manner: x is equal to b to the power y. So this is the exponential form. So you should know when to convert and how to convert the log to exponential and the exponential to log. So for question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we are going to use this same formula for conversion. Okay, so in question 1 to 5, we have been given the logarithmic form and we have to convert it to the exponential form. So as I explained you in the previous slide, that if the log form is log bx equal to y, this is the logarithmic form, then you can convert to exponential form as x to the power, x is equal to base to the power y. So that's what we have used here. So what is the base? For the first question, the base is 15. The value of x is 225 and the value of y is this. So I just apply the formula x equal to b to the power y here. So 225 is going to be equal to the base to the power 2. Similarly here, 1 by 27 is going to be 3, that is the base to the power minus 3. Question 3, 1 by 25 is going to be base, that is 5 to the power minus 2. Similarly here, 243 is going to be 3 to the power 5. 64 is going to be 4 to the power 3. 32 is going to be 4 to the power 5 by 2. So here you convert exponential into exponential form. In question 7, 8, 9, 10 and 11, we are given the exponential form and we are going to convert to logarithmic form. We use the same equation. So here if you see, 2 to the power 7 is the value of b to the power y. So the base for the log is going to be 2. So log 2, this number, which is the value of x, 128, is going to be equal to y, which is 7. Similarly here, we apply the logarithmic form. So log base 3, 1 by 81 is going to be minus 4. And so on. You can see the solution for the remaining question. Let's now solve these equations. Here you see two variables x and y. You have to solve for the variable x, so you can give your answer in terms of y, and we are going to use the method of cross multiplication in some of them. So the first one is x to the power 4 is 2y plus 5. Now we have to find the value of x, so I'm going to isolate the x and move the 4 on the other side. So it becomes 4 to the power, 4 multiplied with 2y plus 5. Now whenever you have brackets, remember you are going to distribute and multiply. So this is going to be 8y plus 20. So that's the value of x in terms of y. For this one, again, we need the value of x. So what I'm going to be doing, I'm going to move this 5 over 6 on the other side. It becomes y plus 5 over 6. Now this is equal to 2 by 3 multiplied with x. But I need the value of x. That means I'm going to multiply both sides with the reciprocal of 2 by 3 so that it will collapse. So it is going to be 3 over 2, 3 over 2. I hope you're able to understand why I've multiplied with 3 over 2, because I need to isolate my x and I will cancel 3 with 3, 2 with 3. So this is going to be x equal to 3 by 2 times y plus 5 by 6. Now you can also open the brackets and multiply as well. Again, for finding x here, I'm going to isolate the x. So I can move the 9 on the other side. It becomes y minus 9 is equal to minus 4x. Now I have to divide both the sides with minus 4 because I want to isolate my x again and I want to get rid of the number here. So the value of x is equal to y minus 9 divided by minus 4. This one again, we have to find x, so I'm going to move y on the other side, so it becomes y plus 7 and I divide by 2. So that's your x value. Very easy questions. So you can check your solutions. This is what you are going to get when you solve these questions. Now, if you see question 1, 2, 3, 4, 5, 6 is very similar to the kind of questions we did in the beginning of the session today, where you convert, if you see log is given, so this is the logarithmic form, you have to convert the logarithmic form to exponential form. So log to exponential. So how do you do? If you have log base x equal to y, this is the equation, then this is going to be equal to base to the power y equal to x. So we are going to use this exponential form for the conversion. So let's use this formula for solving the questions 1 to 6. So here what is the base? The value of b is 15. The value of x is 225. The value of y is 2. So I'm going to convert it into this form. This is the exponential form that we want. So x is going to be equal to b to the power y. Okay, that's how you convert. Similarly here, what is the base? The base is 3. The value of x is 1 by 27. The value of y is minus 3. So I'm again going to use x equal to by. That means 1 by 27 is going to be base to the power minus 3. So I hope you've understood the pattern. I'm going to write the answers quickly now. So base to the power minus 2. Similarly, 243 is base to the power 5. 64, that is this, is going to be 4 base to the power 3. 32 is going to be 4 base to the power 5 by 2. So this is the conversion. For question 24, 25, 26 and 27, we need to do the graph. So answer will be in the next slide. We also need to find the intercepts, that is x and y intercepts, the domain, that is the input, the range, that is the output, and the end behavior. So let's solve them one by one. Here on the left, you can check your answers for question 1, 2, 3, 4, 5, and 6. Let's move on to the graph questions now. So the graph of log 1 by 9 to the power x. So if you see the base, first is that you have to identify the base. The base is 1 by 9. And then there are 3 points that you are going to use to draw the graph always. So first you are going to use these points, use these dots, and then you will draw a smooth curve, join the dots, and make the graph. So what is the first point? 1 by b comma minus 1. Please learn these coordinates so that you may draw the graph easily. If this comes on pen and paper, then 1 by b comma minus 1 is going to give you the first point 9 comma minus 1. Second point is always 1 comma 0, and the next point is b comma 1, which is this point. So graph these 3 ordered pairs and draw a smooth curve through the point, and this is how the graph is going to look like. Now observe the graph. We have to find the intercepts of the graph. So the x-intercept is the point where the graph touches the y-axis. So if you see carefully, it is touching at 1. So the graph intersects the graph intersects the x-axis at 1. This is the point 1. So the x-intercept is 1. However, the graph does not intersect the y-axis. It is looking as if it is intersecting, but it is very, very close, infinitely close to the graph of y, but not touching it. So there is no y-intercept. Domain is input. It comes from the x-axis. So it is all positive numbers. There is no part of the graph which is on the negative side of the x-axis. So therefore the domain is going to be 0, infinity in the positive direction. The range is all numbers, which is positive and negative both, as you can see from the y-axis or your output. So minus infinity to infinity is the range. End behavior is the behavior of the graph towards the endpoints. So on this endpoint, as x is going to negative, fx is going towards minus infinity. So as x is going towards 0, positive direction, fx is going up, up and up. So it is going towards plus infinity, going up. And on the right side, this is the behavior on the left endpoint. on the right side you can see as x is going to plus infinity, fx is also going down. Down means it's going to minus infinity. So this is the end behavior. Let's come to this graph. Again, you have to identify the base. Here the base is 1 by 5. I'm sure you have learned the 3 points that we are taking. So 1 by b comma minus 1, 1 comma 0 and b comma 1. Graph these 3 ordered pairs and draw the smooth curve through the point. So you will join the 3 dots and this is how the graph is going to look like. If you see, the end behavior for both the graphs is same. Their shape is also very much similar. The graph is intersecting the x-axis at the same point 1, so the x-intercept is 1. However, it is not meeting the y-axis. Again, y-axis is acting like an asymptote. The graph is very close to the y-axis but not touching it, so there is no y-intercept. The domain is again all positive real numbers 0 to infinity. The range is all real numbers minus infinity to infinity, and the end behavior, as discussed on the left, the graph is going up and up towards plus infinity. So as x goes to 0 from the positive side, that means this side, fx is going to infinity, and as x goes to plus infinity, that means on the right side fx is going down, so minus infinity. Let's also discuss question 26 and 27 in a similar manner. So here you have to take the same 3 points that I have explained to you for drawing the graph. Once you draw the graph, from the graph you have to observe the intercepts, the domain, range and end behavior. So let's discuss them one by one. The graph is meeting the x-axis at 1, so definitely there is an x-intercept. It does not meet the y-axis. Y-axis is acting like a vertical asymptote, very close. The graph is there but not touching, so no y-intercept. Domain definitely is all positive real numbers because there is no negative value of x. There's no part of the graph on the negative side of x-axis. It's all here. Therefore, it is domain 0 to infinity. Range is all real numbers. That means from minus infinity to plus infinity. As you can see, all y values are taken by the graph. End behavior, as x goes to 0 from the positive side, the graph is going down and down, so fx is going to be going to minus infinity, and as x goes to plus infinity, the graph is going up and up, so fx is going to be going to plus infinity. Both the graphs have the same values for the domain, range and end behavior. Okay, let's solve these questions now. These are very easy. You have to find the value of the unknown variable and write your answer in simplest form. The common method that I'm going to be using for solving these all questions is cross multiplication, which most of you must be aware of. So I'm going to just cross multiply the numbers that you see here. Okay, and 5 multiplied with 3 is going to give you 15. 14 multiplied with 1 is going to give you 14, and x is as it is. So in order to find the value of x, I'm going to isolate, that is I'm going to divide both sides by 14. So 14 colors, so here x is 15 divided by 14. Next one, I'm going to cross multiply. 8 multiplied with 4 is equal to 5 multiplied with k. That's going to give me 32 over 5 as the value of k. So all questions we are just cross multiplying and isolating the variable here. So your m is 56 divided by 3 and your p is 63 divided by 10. So I have given here the answer in terms of the fractions. If in your ministry exam you have to convert it to decimals, then you may divide and give your answer round to 1 decimal place. You can check your answers here. These are the answers for question 1 to 4. Next, we're going to simplify each expression. The concept that I'm going to be using here is called LCM, or least common multiple. We use this method when there are different denominators. As you see in these questions, the denominator here is 4 and 8. So in order to make the denominator equal, I take the bigger out of it. So 8 is the LCM here. So now I take the numerator 3 of 8 divided by 4 is 2. So I'm going to multiply with 2. And this 7 over 8 already has an 8, so I'm just going to multiply with 1. So 6 minus 7 over 8, this is the simplest fraction, minus 1 by 8. Now look at this question, 9, 6 and 3. There are three different denominators. So the method, in case you have forgotten to find LCM, I'm going to revise for you. You start dividing the three numbers with the common multiple. So 3 is common. So 1, 2, 3. Again, I do with 3. 1, 2, 3. Then I do with 2 and I do keep dividing this till I get 1 on all sides. Now that I've got 1, the LCM is 3 multiplied with 3 multiplied with 2. So the LCM is going to be 18 here. So that is the common denominator. Now the denominator is common. So 18 divided by 9 is 2. 8 multiplied with 2. 18 divided by 6 is 3. So 7 with 3. 18 divided by 3 is 6. So this is going to give you 16 minus 21 plus 6 over 18, or 1 by 18 as the simplest fraction. Again, in a similar way, I would want you to do the LCM of 10, 15 and 3. And when you do that, let me write the smaller number first. I do it with 3 first. So 1, 2, 5, 2. So here are the numbers, 5 multiplied with 2 multiplied with 3. So the LCM is going to be 30 here. So I make the denominator equal, take 30 here. So this is going to be 9 multiplied with 3 minus 4 multiplied with 2 plus 1 multiplied with 10. And this gives you 37 minus 8 over 30, that is 29 over 30 on simplification. Again, we do the same method of LCM, make the denominators equal. The LCM comes out to be 6 here. So 10 multiplied with 2 plus 5 plus 3 multiplied with 6. So this is going to be 43 over 6. So these are the answers for the quick check here. Giving you an answer key for question 5, 6, 7 and 8 for the final answers in terms of fraction. So for each of these questions, 1 to 6, we have to multiply and divide the rational expressions. We are going to simplify each expression, and we also have to say when the original expression is undefined. So the method that you are going to use here is to factor the denominator and numerator wherever necessary. When I say factor, what I mean is that if you see a quadratic expression like x square plus x minus 12 or y square plus 3y plus 2, in the numerator or the denominator, you have to find its factor. Also remember, the original expression, the rational function, is undefined when the denominator becomes 0. So when the denominator is 0, you are going to get the value of x when the original expression is undefined. Okay, so you have to look at the denominator. For example, the denominator here is 2y multiplied with y minus 4 multiplied with y plus 2. So this one is going to be undefined at 3 points. One is y equal to 0, one is y equal to 4, one is y equal to minus 2. So at the points where the denominator is becoming 0, that is when the rational function would be undefined. So we are going to use this concept to get to the solution. So let's see the solution on the next slide. Look at the first question here. The denominator can be factorized using x plus 4 and x minus 3. We are using middle term splitting for doing the factorization, and then you can cancel the common factors or eliminate them from the numerator and denominator. So x minus 3 is common, we cancel it, and what we are left with is x multiplied with x minus 6 divided by x plus 4. So this is the simplified expression. Now, by zero product property, the expression is undefined as the denominator is 0. So when you see this part of the question, the denominator has two parts, x plus 4 equal to 0 and x minus 3 equal to 0. So this gives you x equal to minus 4, move it on the other side, and x equal to 3 as the 2 points where the expression is going to be undefined. Let's go to question 2. Here you have in the numerator a quadratic expression y square plus 3y plus 2. So you factor it, and the factor comes out to be y plus 1 and y plus 2. Cancel the common factor, which is y plus 2, eliminate 1y from the numerator and denominator, and what you are left is the simplified expression. Now by zero product property, the expression is going to be undefined at 3 points. As I told you, we look at this part. So the denominator has product of 2y equal to 0 means y equal to 0. Y minus 4 equal to 0 means y equal to 4 is the point, and y plus 2 equal to 0, that means y equal to minus 2 is the point. So these 3 points, it is undefined. In a similar way, you can see how we have applied a little bit of algebra to factor. So x square minus 9 can be written as x square minus 3 square. So we apply the algebraic identity a plus b multiplied with a minus b. So this is going to be x plus 3 multiplied with x minus 3. Also, x square minus z square can be written as x plus z multiplied with x minus z. So x minus z. I'm just going to correct this. Yeah. So now if you use this factorization, there are some terms which are going to be cancelled. You eliminate the common factor, and this is the simplified expression you get. So the denominator is becoming 0 at 2 points. One is when x is equal to z, and one when x is equal to 3. In a similar way, you can get the answer for question number 4. Let's move to question 5 and question 6. In question number 5, you have a quadratic expression in the denominator, which is x square plus x minus 20. So you are going to factor it. It is going to have the factors x plus 5 and x minus 4. Eliminate the common factor, cancel out the terms which are common, and this is the simplified expression. For calculating the points where the function is undefined, we are going to use this expression, and 1, 2, 3, there are 3 points. The first point is x equal to 0, the second point is x equal to minus 5, and the third point is x equal to 4. So wherever the denominator becomes equal to 0, remember by zero product property, the expression is going to be undefined. Now question 6 is an important question. You may get it in your ministry exam. If you see, you have to factor here both the numerator and denominator. So y square plus 2y minus 24 can be factors as y minus 4 and y plus 6, whereas y square minus 12y plus 32 can be factored as y minus 8 and y minus 4. So you will cancel out the common terms, eliminate the common factors, and write the simplified form as this. Again, when this expression is going to be undefined, it is going to be undefined at 4 points. First point is y equal to 0, y equal to 0, a repeated point, because y square equal to 0 is going to give you y equal to 0 2 times, and then y equal to 8, because y minus 8 is going to be 0, that means y is going to be 8, and similarly y is going to be 4. So at these 4 points, the graph is going to become undefined by the zero product property. We have come to the end of today's session for grade 10 elite. I was not able to complete the whole part 1, but don't worry, I'm going to make another video for part 1 with the remaining questions. This video was becoming too long. It was almost 30 minutes long, so it will be very difficult to upload longer than that video. So I'm going to just post this video now. That is all from my side for this session. Thank you for joining, those who did. Don't forget to like, share and subscribe to the channel, and all the very best for your coming exams. See you in my next video. Bye students.